In this video, we use the molarity equation in combination with balanced chemical equations to carry out some very useful stoichiometric calculations for reactions in aqueous solutions. You may recall from an earlier video in this series that we were presented with this stoichiometric problem: the combustion of butane in the presence of oxygen to produce carbon dioxide and water, and we were given 5.78 grams of butane and asked to find the mass of carbon dioxide produced. And you may recall that the way we tackled these particular problems was to use an approach outlined here, where in step 1, we first convert the mass of butane into the moles of butane using the molar mass equation, and then in step 2, we convert the moles of butane into the moles of carbon dioxide using the ratio of the stoichiometric coefficients from the balanced chemical equation. And then finally, in step 3, we convert the moles of carbon dioxide into mass of carbon dioxide using the rearranged version of the molar mass equation. With this type of problem, application of the molar mass equation and its rearranged forms is crucial. Now, with our knowledge of chemical reactions that take place in aqueous solutions, and with our knowledge of the molarity equation, we are in a position to tackle a much broader array of practical problems. For example, consider this scenario here. What volume of a 0.15 molar magnesium chloride solution is required to exactly react with 75.0 milliliters of a 0.12 molar silver nitrate solution? The relevant balanced equation is this one here, where we can see that this reaction is actually a precipitation reaction with the formation of solid silver chloride as one of the products. To solve this problem, we can take the same approach as we have done previously by writing out all the information we have been given. For example, we know that we have 75 milliliters of silver nitrate solution with a concentration of 0.120 molar or moles per litre. We also know that we've been given the information that the magnesium chloride solution has a concentration of 0.150 molar. And we've been asked to find what volume of that solution we require to react exactly with the silver nitrate solution. So, in other words, we've been given information about the volume and molarity of one aqueous solution, solution A, and in this particular scenario, we've been asked to find the volume of another aqueous solution, solution B. In other scenarios, we may be asked to find its concentration rather than the volume. The approach we take to solve these types of problems is very similar to other stoichiometric problems in that we first calculate the moles of substance A in step 1. But this time, instead of using the molar mass equation, we use the molarity equation, where we have moles as the subject of the equation, and we calculate the moles of substance A by multiplying molarity times litres. In step 2, we use the ratio of the stoichiometric coefficients to calculate the moles of substance B, and in step 3, we again use the molarity equation, or one version of it, to calculate either the volume or the molarity of substance B, depending on which of the two we're being asked to find. So going back to our specific scenario, in step 1, we calculate the moles of silver nitrate by multiplying concentration and volume in terms of molarity and litres. And this gives us 0.120 moles per litre times 0.0750 litres. And you will note how we've converted the 75 millilitres into litres in order to do this calculation. And we get the answer of 9.00 times 10 to the minus 3 moles of silver nitrate. In step 2, we calculate the moles of magnesium chloride from the moles of silver nitrate using the ratio of the stoichiometric coefficients from the balanced chemical equation. So moles of MgCl2 equals 1 on 2 times the moles of AgNO3. The 1 comes from the stoichiometric coefficient of the substance we've been asked to find information about, divided by 2, the stoichiometric coefficient of the substance we've been given all the information about. And that equals 1/2 times 9.00 times 10 to the minus 3 moles, the value we just calculated in step 1, and that gives us 4.50 by 10 to the minus 3 moles of magnesium chloride, MgCl2. Finally, in step 3, we want to calculate the volume of the magnesium chloride solution using the appropriate version of the molarity equation, litres equals moles divided by molarity. This gives us the 4.5 by 10 to the minus 3 moles we just calculated in step 2, divided by the molarity, 0.150 molar, which was given to us in the question. Plugging those numbers into our calculator, we get 0.0300 litres, which we can convert to 30.0 millilitres if required. So in summary, the answer to this question is that it takes 30.0 millilitres of 0.150 molar magnesium chloride solution to react exactly with 75 mL of a 0.12 molar silver nitrate solution. And remember, we were able to solve this problem by carrying out these 3 steps. Step 1, converting the molarity and volume information of substance A into moles of substance A using the appropriate version of the molarity equation. Step 2, we converted the moles of substance A to moles of substance B using the ratio of the stoichiometric coefficients in the balanced chemical equation. And step 3, we converted the moles of substance B into either the volume or the molarity of substance B, depending on what we are being asked to solve, by using an appropriate form of the molarity equation.